All right, yeah, welcome back again. And we want to look at today what outlier is and how to manage outliers in our data set. What is outlier? Is the random component of measurement error. Any data point that is significantly outside the distribution's mean or median is an outlier. This outlier we are talking about most times cannot be avoided. It always comes along with your data set. Unknowingly to you, you may find one or two in your data, then you should be able to deal with it. It is nearly always present in data and can sometimes be difficult to get rid of. So outliers are something we should remove from the data set so that it doesn't skew the model. There are many causes of outliers actually. It may be intentional dummy outliers created to test detection methods sometimes. It may be data processing errors. When data is being processed, some errors ensue, data manipulation or data set unintended mutations. Sometimes it might be sampling errors, extracting or mixing data from wrong or filtered sources. Bring data from this source, away from that source, combine together. There may be an issue, not only with the metadata, but even with outliers. And sometimes data entry errors. Maybe when you are entering data, you are dosing, you are tired, and you did something wrong, something different in your data set. So there are many things that will cause data outlier of data. So what we do, we handle it. Maybe you may not understand what I mean by the outliers practically, because some of us we are not familiar much with data. But experientially, for example, if you want to do a research and you have a scope of data set you want to collect, maybe your scope of the data set you want to collect, the inclusivity is based on children between age of 5 to 10 years. 10 years old, that is your the scope. Okay, you don't go less than 5 years old, don't go above 10 years old. That is your inclusivity. So that is your scope. But while you go for data set collection, you collect your data, and while you are looking at data, you now find out that you see in the age group there, you see 15 years of age, 20 years of age. That is outlier. Yes, that is practical explanation now. That is outlier. So you have to wonder, how did it get here? I think my scope is between age of 5 to 10. So how come I'm seeing 15 years, 20 years of age? That is too much. That is called outlier. All right. So you have to know what to do because that will be far from the mean or the median of the data set. So you have to handle it, get into it, or whichever way you want to do it. There are many ways to handle that actually. So that is now left for you. So let's see how to handle outlier. So the first thing we want to do is to understand that we have outlier first. All right. So I'm going to be running this library called the looker, so it will help us to run run outliers and imputation. So the data set we'll be using is called empty cast again. So it's already loaded in the library, so you just want to load it again. So I've glimpsed before, so let me glimpse again so that you can see what is that empty cast. So we have empty cast, we have 32 rows and 11 columns. So I've done this before, so I think now you should have get familiar with empty cast. So you can check one by one by using box plots. Okay, box plot to see this particular data set, to see outliers. If you run this, for example, this box plot that are weight, for example, don't mind those money, okay? Just money, these are just money, they're not errors, they're money, don't mind those, so just ignore the money. Alright, it happens in R and in Python all the time. Alright, so we run this line, okay? You can see there are two outliers here too. Alright. This anything about this whiskey line it is outlier. So using box plot as example, okay? You can also use another maybe key plot to see that outliers. So you might want to say, let's see if for HP, let's say HP, you have outliers here. Yes, we have one. You can see we have one. Okay, we have for MPG. Let's see for MPG. none, no outlier. What of displacement? We have displacement, okay, no outlier. You can see you can easily dictate outlier very easily using your data. But what of if you want to know which one is outlier among them? How many? You have seen that for this one, I saw that they are two in number because they can be seen very easily from this chart. But what of if there are many? Okay, they just stack upon themselves like that. You not know how many they are. All right. So you can use something. Like for example, if I for my WT now, which is two, which is weight, I can say dollar out. I can say dollar out. All right. This one will help me to see which one among my data is outlier. Okay, this method is very important and powerful. So you can simply do something about it. For example, if I have 50 outliers, show me. I want to see those 50 outliers. I want to see them. That is many of this. So if you use this method, if you run this method now to display, look at what you show me: 5.428, 5.3. This now they are outliers, both of them. So it show me the outliers in this particular weight. So because I only have two, you can see. So it's giving me the two outliers that I have here. So if I have 50, automatically it will display 50 here. So that is how to see your outliers. So take note of that. So now let's move further. I want to first diagnose. The diagnose function comes from this the looker. Okay, when you use the looker, you can pass in your data set, which is empty cars. Then which variable do you want to diagnose? To diagnose FPG, HP, WT, displacement, okay, miles per gallon, horsepower, weight, and displacement. We want to diagnose all those ones. So what we do, we run this diagnose capacity. Don't forget this is our data set name, and these are the variables. So you understand. So when we do that, let me just stretch so I can see properly. When we do that, we do to give you the diagnosis. Let's run this line. So we run this line now. You can see diagnose, show you variables, APG, horsepower, and so on. Now you say here has no outliers, zero. Of course, we have seen that there's no outlier before using our graphical output. Now HP has one, you can see, and the WT has two, you can see. So displacement has none, which is zero. So no outliers. Only these two have that is having outliers. So what do we do? Now we don't have to get it of it, so I don't need to run this anymore. I've already run this, okay? So what we do now, we want to do corrections of outliers now. Alright, we want to do imputation. So correction of outliers for one variable first. We're not going to run this, okay? So this one, if you want to do correction for one variable, maybe I want to do it with only HP or WT, I can just run. I pass my empty class here, data set, then I pass HP here. I don't need to put this one actually. I can leave it there. I can just pass HP here and put capping here. Capping is the method we are using. There are many methods you can use. You can use mean, you can use median. Okay, let me show you. Here, if you type here, impute, put outlier. Okay, let me just put let's put some mark here. Right. Okay, so let's check. Now this particular function, this outlier here, is giving us more information here, right? It has a different kind of method here. There's no attribute to mean logical true if return numerical variable. Don't want those stories, so we can say false. Now, if you go further, another method of missing values imputation. We have main method, which is arithmetic mean. We have median, we have mode, we have capping. So we are using capping. Capping impute the upper outlier with 95% percentile and input the lower 55 percentile. You can change the criterion. So this is called method for our outlier. So whichever method we want to apply, can apply here. So but we want to use capping because capping seems to be the best method by experience. Right? So you can just play around them. You can apply here. You can put mean, you can put median, you can put mode. Okay, just play around the methods and see which one that is good for you and for your data. So now we want to use capping because I have tried each of them. I saw that capping is better for this data set. So, but we want to use a multiple correction now, correction of outliers for multiple variables. So we because we want to pass. So we want to introduce our what do you call it now? Our piping method here. Okay, we want to pipe it because we want to retain the empty cars data set and use it to create a new data set now, new empty cars. All right. So while we still retain the other variables inside the empty cars, so we want to create a new variables in addition to that. Right. So what we want to do? So we are going to mutate first. We call our empty cars data set. We mutate. And that mutation, that's when we run our imputate method. Here we run this guy, okay, for multiple. So we create this new variable, call it let's just say IMP. It means imputate, okay, nothing special. You can call it HP dash HP something like. So, but it is actually new HP. I'm trying to create. I can call it new HP. Okay, okay. We call it new HP. Let me make it new HP so that you can understand better. New HP, new weight, new weight. All right, that is better now. Okay, so we say imputed outlier. We call empty cars. This is a preforce HP, right? That's what we want to handle. Okay, method is capping, no attribute equal to true. All right. So comma, we are done with the first one. We are passing the second one at the same time. New weight, because weight also have outliers. Call the same method. So you can just copy and paste, okay, and pass a weight here. The method equal to capping, no attribute. That's finished. Okay, you save. You run. So if you run this one now, we have a new empty cars, which means new data set entirely. That includes both HP and new HP, both WT and new WT is included. We have created more two variables now, which we are passing our data in, our new HP in and new WT in. So let's run this and see what I'm talking about. So it has run. So let's see what is inside there. That you can just call new empty car, new. Let's glimpse. Let's just glimpse it. Glimpse new empty cars. So let's see what's inside. Alright, so we glimpse now. Can you see? We have more two variables added. It's called new HP and new WT. You can see. So the original one is here. The original one is here. The original one is here. So we have new one. So when we are done, we can drop the old one and retain the new one. That's what it means. That's the purpose of that using this particular piping method. Piping method will retain the old one and create a new one for you. Alright. So you don't need to be creating one by one and now be editing one by one. So you see you have everything complete. Alright, so let's diagnose this new one that I've created. Let's diagnose it again and see. So we can diagnose using the same method now, and we pass our new variable called new data set. We create called new empty cars. We have our new HP now, so I change it just now. New WT. See if we see have outliers here. Alright. If I run this line of code now, it should be able to show me if there's outlier or not. Okay, so now we have outlier 0. So no more outliers. That's what it means. You can confirm that by your what they call it now, by plotting. I don't need to glimpse anymore. I've already glimpsed. Let's plot this empty cast. Let's plot again for our new. Okay, this old one. Okay, this old one. Let's first plot the old one and see this old one. See, I have one, right? We have two as usual. So for this new one we created now. For this old one, okay, empty cast. This new one. Okay, let's say we have new one now. New WT. Let's see if we have anything. So it has gone. For HP also, let's say we have new HP. Let's see, we have one before. Now that's gone, no more. So that is how you remove outliers from your data set. Okay, we have done what is called imputation method to handle outliers properly. So you can save the new data set now. This new one that we have created now, this new one, you can save it in our this and open in Excel. Okay, just it will save your working directory. I hope you have created. You have to do that. Create working directory. If you have not done that using this method, you choose and create a new one, or just use your source file directory. Anyone you want to use is better for you. You can just use it, create it also manually using code. So if you run this line of code, that will save. Okay, already save my directory. So I can open in Excel. I have a new data set. I can now remove the old one and change this new one to HP, new one to WT. That's all. Okay, so that is that for today under managing outliers. So you can try to replace it with your data set and see how you can work around it. It's very, very easy, Very, very simple. I will see you in the next class. Thank you so much.